Hey, welcome. Here we are. Today we're going to continue to kind of play around in the world of fractions as we start to understand more of what we're doing here and what these mean. And today I would like to spend a little time talking about two equivalent forms of fractions. I'll use that term lightly. And that would be a top-heavy fraction and then a mixed number. I guess technically a mixed number isn't a fraction, but it has a fraction. That's why I said I'll kind of use that loosely. But we're going to look at like how is it that we get these pieces to look equivalent and really what they mean in terms of modeling. Okay, so if we just start, right, the concept of a top-heavy fraction. Let's start over here, top heavy. This is often called an improper fraction. And what that means is that you have a numerator, that top number, you have a numerator that is larger than your denominator. Which means really you're working with something that's greater than the whole. Okay, so like an example of that might be, we have something like 5/3, right? And as you can see, yeah, the numerator, the top of the fraction, it's larger than the denominator itself, which means it's really more than what we have. And we have to think about like, what does that mean as a model? Like what's happening here with that, right? So let's break that apart. Let's do that now and think, okay, well, I have this denominator of 3. I have this denominator of 3. Well, the denominator tells me the total. So what that means is if I was to do like a fractional part, well, I would have my model, and according to the denominator, I have 3 sections, right? I have 3 parts. And then we know with the numerator says, oh, well, here is how many we have. Well, we have 5 of them. So if we started to shade that in, this would be 1, 2, 3. Now what, right? That's 3. I need a 5. That's 3. What? I have 5, but here I only have 3, right? So we have to realize, oh, okay, well, then I just need to create a second hole, right? That was one hole. Now I need to make a second hole. And this is still a thirds. And let's see. So I did 1, 2, 3, 4, and 5. And that's what 5/3 would really look like. And again, like I said, that's more than 1 because look at what we have here. This I'm gonna sorry denominator and numerator. This piece right here, that's all of it. That's 3 out of 3, which is the same thing as one whole. And then this right here is 2 out of 3. Right, so if we put that together, well, there's 3/3 and 2/3, so 3 plus 2, there's my 5, and then it's thirds, so that stays the same, right? So I actually have more than a whole. That's a top-heavy fraction. So let's look at that some more. Let's keep playing around because I know often first time you're like, oh, what? I don't know, and that's okay. So let's play with 6/2. Okay. So again, we know this is top heavy because the numerator is larger than the denominator. But if we were to start to model this, we got to pay attention to the denominator. I mean, that's the key. The denominator tells us everything. What the denominator says is, oh, well, you have a model and it's cut into 2 pieces. It's halves, right? But your numerator says, well, you have 6 of those shaded in. Well, if you look at my first model, I can't shade in 6. I can only shade in 2. 1, 2. So I guess we'll have to make another one, right? And then that would be 3, 4. Well, I still need 6, so let's do another one. 5, 6. So this idea that I have 6 halves, actually, when we put that together, look at here. This is one hole right here. And this is another hole right here because I have all of it. And this is another hole. So that's actually just 1 plus 1 plus 1. 6 halves. This is the same thing as 3 holes. They're equivalent. That's what that means. I have more than I need with a top-heavy fraction. Okay, so top-heavy fractions, they kind of carry this idea of having more than the whole. Now, let's look at a mixed number, right? So a mixed number is called a mixed number because it is a mixture of two things. It has a whole number and it has a fraction. So your classic example of that might be something like I have 3 1/2, right? So there's my whole number, here's my fraction, that is a mixed number, right? So 3 1/2. So like if we were to model that, let's think about that. Well, 3 1/2, what does that mean? We'll pay attention to our denominators. Let's pay attention to the denominator. And it says that I have halves, right? Everything I have is cut into half. So I'm going to do that. But I also have to think about my whole number. My whole number says, well, I have 3 of those that are already full. So here's 1. That's already 1, so I got to fill that in. There's 1, 2, right? That's another whole. 3, that's another whole. So that's 3 holes. And then if we look at what's left, I have 1/2 left. So that's really what we would see is 3 1/2 if we were to model it. Sorry, there's the good old circle everything, and then it gets confusing. Right, here is 3 1/2. Here it is as a model. One hole, 2 holes, 3 holes, and then 1/2 left over. And if we thought already now, okay, well that's a mixed number. Well, what does that mean as a improper fraction? What's the equivalent? We can actually just count that. Look at this. We still have halves, right? That's our whole model is halves. And how many halves do we have? How many halves do we have? We have 1, 2, 3, 4, 5, 6, 7 of them. So this would be 7 halves, which is the same thing as 3 1/2. And here is a model that supports that. So that's what this idea is about whole number or mixed numbers and improper fractions or top-heavy fractions. So we talk about like how do we convert them? How do we go back and forth? So let's just start with that. Let's start with a mixed number. I have 1 3/4. Okay. All right. Well, to help me find that, I'm just going to model what that says, and I'm going to pay attention to all my pieces. The first and most important part is the denominator, right? And the denominator tells me that I'm taking my model and I'm cutting it into 4 pieces. Well, that's great. There's 1, okay? And, okay, sure, let's do that. It says I have 3 of them, 1, 2, 3. So that would be the fraction part of it, right? There's the 3/4 part. But we also have to remember that we have this 1 whole. So this model also has a whole. And that whole is still cut in the same amount of pieces as the denominator, which means 4, so I have to do that. But it's all of it, so I'm actually going to shade it all in. And then if we break that apart, we can just count what we have, right? We know we have 4s. That's a given, because look, it's the same. They're both cut into 4s. We know there's 4s. How many do we have? We have 1, 2, 3, 4, 5, 6, 7. We have 7 fourths. So 1 3/4 is the exact same thing as 7 fourths. These are equivalent in terms of mixed number and a top-heavy fraction, same thing. Typically, we want this. As you can see, if you've already watched the addition or subtraction videos, you would see this. But if you haven't yet, this is going to come in really handy when you do the addition videos, because you're going to see, oh, that's what they're talking about there. We're kind of mixing them up here. So let's play around with that some more. Let's convert the other way. Let's say I have 10 thirds. Well, what does that mean, right? Well, that means I have a model, and it's definitely cut into thirds, right? Denominator, always my friend. And now the numerator says, well, 10 of them need to be shaded. Well, here's 1, 2, 3. Well, there's only 3. I need 10, so I guess we'll make another model. Okay, so 1, 2, 3, 4, 5, 6. Okay, so that's not enough. So let's make another model. 6, 7, 8, 9. It's still not enough. I need 10, so let's make another model. So 1, 2, 3, 4, 5, 6, 7, 8, 9. and 10. So there's 10/3. So what does that mean as a mixed number? How many holes do we have now? Well, how many boxes have I completely shaded in? There's one here, there's one here, there's one here. So that'd be one hole plus one hole plus one hole. So 10/3 is going to be the same thing as 3. And then what's left over is 1 out of 3. So 3 and 1/3, 10/3, these are equivalent when we're thinking about going back between mixed numbers and top-heavy fractions. So of course, we will do another. Let's go with a mixed number this time. Let's say 2 and 2/3. Okay. All right. So then let's break apart what this means as a model, right? How do we put this together as a top-heavy fraction? Well, I know according to the denominator, and again, always start with the denominator. It's going to help you so much. That means that every model I have is cut into thirds. So I'm going to start with one model. I'm going to cut it into thirds. I did not really like the way I did that. So let me make that a little bit prettier. Okay, it's thirds. So then let's also just, that's going to be one model, but let's also pay attention to the whole number. And the whole number says, well, I have 2 of these models that are filled up. So here's one model. Here's one hole, so I got to shade in all 3 of them. And then here would be my second hole, right? Because that's what that whole number says, underlined in red up here, right? That's 2 holes, and that's what you see here. That's what this is. It's 2, 1 plus 1. And then if we look at the fraction part that's left over, it says, well, we have 2 out of 3 left over. So we got to make another model, and again, it's still in thirds, but only 2 are shaded. Now, if we look at that, we just want to say, okay, well, my denominator hasn't changed. That's one thing we need to notice. This is happening a lot. It happens with addition and so on. It's like the denominator isn't changing when I'm putting these together. So it's still thirds, but how many thirds is it? Well, I got 1, 2, 3, 4, 5, 6, 7, and 8. I have 8 thirds. So again, we have 2 and 2/3 is equivalent to 8/3 as a top-heavy fraction. These are the same things. It's just I'm showing them in the 2 different ways. Okay, so let's play with one more. We'll go the other way from top-heavy to mix. I'm going to call it 13/4. Okay, again, denominator is our friend here. Because the denominator says, oh, well, I have a model, and it's cut into 4 pieces. Okay, and according to the numerator, I have 13 of these pieces shaded in. So let's start with that. So that's 1, 2, 3, 4. Well, that's not 13. That's not enough. So let's build another model. Okay, so I have 4, 5, 6, 7, 8. Well, that's not enough. I need another model. So I was at 8. Let's see here, 9, 10, 11, 12. That's still not enough. So let's do another model. 13, right? So there's 13 of these fourths. But now we want to think about, well, what's the mixed number? So let's look at how many holes we have. Here's a hole, right? Because the whole thing is shaded in. Here's another hole, because again, all of it's shaded in. And here's a third hole. So that's 1 plus 1 plus 1. Well, let's see, 13/4 then equals 1 plus 1 plus 1. That's 3. And, well, what's left over here? What fraction does that say? It says I have 1/4. So there you have it. Okay, so this is just a start. Like, keep practicing with it and ask the questions. But this is what we really want to think about when we're converting mixed numbers to top-heavy fractions and top-heavy fractions to mixed numbers. As always, thank you for your hard work. Let's keep up the great work, and we'll see you soon.